So limits are a way of finding the value of a function, basically. At or around a given point. X equals A, even if f of A, that function at that point, doesn't exist. And so what a limit is basically we approach the point x equals A, which I'm saying x equals A. It could be any point, on the function. By following the function from either side. All the way into an infinitesimally close neighborhood. Which is really just a fancy way of saying that if we have a curve, it could be any random curve. Let's say we wanted to find the function value at, this is our x equals A. Well, for this, if we knew the value of the function at x equals, or if we knew the equation of the function, excuse me, then we could just plug in f of A because this point it's on that curve, right? So we could just plug in x equals A and we'd get the value. But the method of doing it with a limit means that we're literally just following along the curve on either side. And basically testing points all the way up until we get right on the outside of it. And when I say right, I mean like an infinite number of decimal places all the way up to that point. We're technically not testing at the point itself, though. So really all we care is the behavior of the function as it approaches that point. And that's important because, well, for some functions, it's not always going to be super clear what, if you just plugged in A, f of A would be. For example, let's say we had function actually let me draw an axis first. Oops. So let's say we had a function that had this strange kind of behavior where it approaches this asymptote on either side. Like that. And let's say this point here is x equals a, where the asymptote lies. All right? So what we do, I mean, if we didn't have the concept of a limit, the only thing we could do is say, well, we could try plugging in f of a, but this function doesn't exist at f equals a. It approaches f equals a, but it's asymptotic behavior. It just goes to infinity. It never actually touches it. So we can't just do that. It won't work. So instead, if we look at either side of this function, well, what is the behavior of this function as it's going towards x equal a? Like what does it approach? Infinity, yeah, exactly. So we would say that f is going to infinity, and in limit terms, now we get into some notation. So the notation for a limit, I'm going to sidestep here for a second. You write a limit of a function like this. So what this is what we call a two-sided limit. But there's also one-sided limits. And what these two mean are, well, this top one is the one-sided limit. Sorry, am I going too fast? Okay, okay. So this one-sided limit on the positive, positive, which means that it approaches from the right. So as we defined it, the limit before, that is the two-sided limit. This one here where it approaches from both sides. And then the one-sided limits are just either side of that. It's like you break up the two-sided limit into either side, and that's what each of those are. So this one with the negative on it is the negative one-sided limit, and it approaches from the left. If I'm writing too fast or anything.
No.
Okay. So yeah, so what we would say here then in our example problem is that the negative one-sided limit, the limit as x goes to a from the negative side of this function, equals infinity. Okay? And then, so the other one, well, what does that approach? Infinity, yeah. So that's also infinity. And so we'd say that the limit as x goes to a positive of f of x equals infinity. So this brings us to an important point. So I'm just going to write important point.
Yeah.
The two-sided limit only exists if, well, I'll let you guess. What do you think is the required condition for it to exist?
If it's like symmetrical?
Yeah, exactly. Yeah, it only exists if the negative and the positive one-sided limits are equal, if they approach the same point. Good. And the limit as x goes to a, so the two-sided limit, then is equal to both of the one-sided limits. So in other words, it only exists if both of the one-sided limits exist, and then it equals what those one-sided limits exist. So in our example then, the two-sided limit is also infinity. Which, by the way, in the notation, I don't know if you saw this, it's a very small detail. The only difference between them is the little minus and plus. Okay. So yeah, that's how we graphically are able to find limits. And the important thing to note here is the limit exists even though the function doesn't exist at that point, as long as it both approaches the same point. And not only is that the case, but the limit as x approaches a doesn't have to equal f of a. So even if the function does exist at that point, that doesn't guarantee that the limit will be the same point. And we'll see an example of that in a minute. So let's do some examples. So we have this here, and I'm going to edit this a little bit. point there. And do you know what the open circles and closed circles mean?
Yeah, it including and not.
Right. Good, good. Okay. So let's do these. So the first one is asking us the limit, the negative one-sided limit as x approaches 0. So now, and this is an important point. The last time I taught this, I don't think I was super clear about it. This is all one function. It's a piecewise function. I mean, we don't have to worry about the equation for it, but yeah, it's all one. So we're looking as it approaches 0, and it's from the negative side. So we're going to follow the function from the left as it approaches 0, like that. So in that case, what would the limit be? Yeah. Yeah, exactly. So it equals 0. Okay. And then the next one is the same thing, but from the positive side. And so we'd follow it like that. And so what would that equal?
0.
No.
2.
2. Yeah, exactly. Because it, on the positive side, it stops here.
Yeah, it's the
You follow it, again, we're not actually going to 0. You follow it all the way up to x equals 0. So yeah, you equal 2. So what about the two-sided limit? It does not exist. Good. You just learned some calculus. Congrats.
See, I've done limits before, but never with like actual numbers. Like it was always infinity at the bottom.
Oh, really? Interesting. Oh, limits add infinity. Oh, I see what you're saying.
Yeah. Like,
We'll get to those. But that's surprising that you did that. Oh, wait, did you do like the definition of a derivative, which is like f of x plus h minus f of
I don't think so.
x over h, and it's like the limit as, oh no, that's the limit as h goes to 0.
We did like limits of polynomial functions.
Okay.
Because I remember when you brought up limits, I wanted to remember because someone made like a fun little graph with like end behavior. It's like the degree and leading coefficient. If it's even or odd or negative or positive, depends on like the end behavior, like up, down, up.
Yeah.
So I was seeing if like that had anything to do with
Interesting.
it. I don't think it does.
I mean, that is
Well,
one thing
yeah.
that you can derive from limits,
Yeah.
yeah. But I'm very surprised that they went straight to limits at infinity. Those are.
I mean, we kind of just like named them, I think, and talked about like the end of.
Let's do the next one. Oh. Okay, so the next one, as it approaches 2 from the negative side. So that would be, it's following the function going to 2.
2.
So remember, don't actually go all the way to 2.
Okay.
Follow the function all the way up to 2 and stop right before you get there and see what, like infinitesimally right before you get there.
Yeah. Negative.
-2, yeah. Okay. And then from the positive side, yes, yeah, good.
And then does not exist.
And then, yeah, does not exist. Okay. And then, so 4. Okay. Keep that there. So 4 from the negative side, we'd be coming up here, following along the function. 4, right. Good. and then
4 as well.
4 as well. Yeah, good.
So two-sided is also 4.
It's also 4. Good. Now, the reason why I added this point here is, and there you'll see an example like this elsewhere, but I wanted to put one in here, is because technically our piecewise function, if we were to plug in f of 4,
It doesn't exist.
it does actually. It exists at 6.
Because you put the point in.
Because I put the
But
point
if
in.
the point wasn't there, then it wouldn't.
Then it wouldn't exist.
Okay.
Yeah, correct. But that's why I wanted to put that in there, because sometimes you'll see that where you have a limit, the two-sided limit exists, but because the point is defined elsewhere, it's not, both the limit and the function is defined, but they're still two different values. And it's because of the method of finding limits that we're not actually going to that point, we're just inching ever closer to it. And the behavior of that function, as it gets closer and closer, it approaches 4. It doesn't, I mean, like, it does not jump like here. If the function like curved up like that, then yeah, we'd have a limit that approaches it. But that's the whole thing, is we're following the function to that point and seeing what it approaches. Okay. Let's do some other examples. All right. So where, for -5, the positive side, where am I going to draw it?
Positive side coming from the left, the right.
Coming from the right.
Like left or right's hard. Up that one. Like
Let's move. Show me.
down.
Yeah. Good.
There.
Good. Okay. And what will that equal?
-3, is it?
Yeah, that's a good point. I should probably write that in there, huh?
It's implied.
Okay. So yeah, -3. Good.
And then the next one coming from the left
Mm-hmm.
and 2.
Good. 2, and so what about the does not exist? Good. Okay.
And then -2 coming from the right.
Mm-hmm. Yep.
3.
Good. 3,
And
yeah.
coming from the left, also 3.
I mean, technically it's like 3.5.
Yeah.
No, I'm just kidding.
3
I don't know.
Yeah.
3 is fine. It's
I
fine.
guess this is the part that comes from making your own.
Exactly. Don't talk crap about my.
No, it's great. The lines are very smooth. 3 and 3.
3 and 3. Good. So what about the? Or were
Yeah.
you saying?
Yeah.
Gotcha. And what does the function equal at that point? F of.
Does not, -2.
Well, x is -2. What does the function equal?
0.
0. Good. Yeah. Okay.
And then -1. The 2. Or -2.
For -1 from the positive side, yes. Yeah, -2. Because we're going like that.
And then 0.
0. Good. Yeah, because we're.
Down. And it does not exist.
Awesome.
And then 4 from the positive side, like over there. Right?
How would you draw it?
Um,
Yes. Okay.
Infinity?
Infinity. Yeah.
And then negative infinity.
Negative. Well, where? How's it going to draw?
No, it's coming because it comes from this way as well.
Yeah.
I forgot about that one.
It's all good.
So -2.
Good. Yeah, -2. And
Does not exist.
does not exist. All right, cool.
Yay.
Well, oh crap, we are over time. So that ends it for today. I'll make a